The heat of combustion per CH2 of several cycloalkanes listed below. Based on the data given, which of these cycloalkanes would be considered most stable? Right, here's our table. So I tried to do a pretty thorough job explaining a couple practice questions from the practice section about heat of combustion. So I don't plan on being as thorough in this video. But one difference, right, in those study questions, the heat of combustions were given as positive numbers. So this is more appropriate to see them in negative numbers, more thermodynamically accurate, right, because this is about the amount of heat released. So these are now delta H values. So, right, we know this is going to release heat. This is a combustion reaction, so you're just going from some type of CH4, O2, goes to water, releases CO2, right? This is same as catabolism, right? Like we take glucose, oxidize it to water, CO2, we breathe out CO2, right? And that gives our body a ton of energy. So we know combustion, just like glycolysis, cellular respiration, it's a energy yielding process. It will release a lot of heat. That's why you sweat when you work out, right? Your cellular respiration is going on. Breathing out a lot of CO2, right? You're running this reaction. So, right, okay, so that's done. So what we want to look at is reaction coordinates. Right, let's move to this side. So, see delta H, reaction progress. So here's reactants, products, right? So we're looking at difference between reactants, products. Most stable would be which of these cycloalkanes? So we all know the reactants for all of these are H2O, CO2. So the stability of, the products, right? The amount of delta H for the products is the same for each of these, right? So the stability of the product is the same for every one of these guys, right? So what's going to make the difference for this problem is stability of the reactant, right? So higher, the less stable, the more unstable, the higher up on delta H this is, the greater the heat of combustion, because that's just difference between reactants and products, right? So this guy right here is the least stable, right? Biggest difference, right? This guy then has most stable, right? Smallest difference between reactants and products, right? So that'd be down there, reactants, products. Right, so stability of the product is same for all these. That's heat of combustion basics. And so also to note, right, for this problem they show that heat of combustion, let's see, decreases as you increase the number of carbons here, right? This is cyclic 4 carbons, 5 carbons cycle, 8 carbon cycle, 10 carbon cycle, right? And shows that heat of combustion is decreasing along that line. But don't take that for granted on tests, right? This is analyzing these numbers here. Don't pay attention to these much. It's all about those numbers. And understanding heat of combustion, it's pretty simple when you get down to it, hopefully. Yeah, so in the end, right, we got answer D. Okay.